Once again, I choose to use a video instead of a text rebuttal. I don't think this will be a permanent change in style, but it's more appropriate to do it like this for the video I'm addressing. This time because it's very long and verbose, but the core error making everything wrong is hidden in something shown and assumed to be correct quite early, and everything that follows is irrelevant due to this wrong assumption. Now let's see what I'm talking about.
During this recent video series, one of the sections covered a diagram that was not to scale, representative of the solar system, the inner solar system, from a top-down 2D view, conveying the point that Mercury and Venus should not be visible from Earth due to the nature of the heliocentric model itself, how day and night work theoretically on a globe. In summary, day is the period which an observer would be on the side of the hypothetically spherical Earth that's facing the sun, and night is the opposite period in which the same observer has allegedly spun, 12,500 miles around a giant curve at 1,000 miles an hour near the equator, and eventually is facing away from the sun after going through the dusk, twilight phase. Now, these two periods in between day and night are called dusk and dawn, or simply...
As described, we indeed should never see Venus or Mars at nighttime, do we? So, why do we? Is every hobby astronomer really this blind? Are all professional astronomers into the global conspiracy? Sounds not very reasonable. Let's take a look what a real heliocentric model of the solar system predicts. I'm using solarsystemscope.com as it's actually very nice and available online for everyone to play with it. But you could use any simulation software to get the same results. If I go to the top view and drag Earth around a bit, you'll see that Venus and Mars are currently, that's in the month of November 2016, on the same side of Sun as Earth is. The same is true for Mars and Saturn, too far out to be in the picture here, but that's only interesting for people that get excited about conjunctions. Now looking at the screen, you can see that it basically looks the same as the Morgile's drawing. The part of the Earth facing the planets is illuminated by the Sun, so it's broad daylight. Switching to the astronomy view and finding the Sun, we see that Mercury and Venus are indeed near to the Sun. At the time of night displayed, well past midnight, all three will be invisible. But let's play around with the time of the day a bit. Approaching sunset. Now the Sun is just below the horizon, but both Mercury and Venus are above it. For Mercury, this is true for about 10 minutes. For Venus, it's about 2 hours. Now there's a reason why Venus is also called the evening star. It's only ever visible in the early evening, never around midnight. And it's a very bright star, so it catches the eye. Unlike Mercury, which is most of the time visible with specialized equipment only. The other situation where Mercury and Venus can be seen, of course, is when they are on the opposite side of the Sun. On the right side in the top-down view, not behind the Sun. In this case, Venus is called the morning star. So how can that be when the side facing the planets is facing the Sun as well? Well, it's really quite simple. The Morgile's drawing has an error. What does sunset really mean? That the light emitted by the Sun is just hidden by the horizon. So drawing a light ray from the Sun to Earth, everything to the left for the evening and to the right in the morning is in the dark part of the sky. The Morgile is right that dusk and dawn are drawn out a bit, But as he mentions himself in the video, the length of dusk at dawn is about half an hour, depending on where you are. So a 2-hour visibility for Venus is ample time. And Mercury? Well, Mercury sometimes does have a bigger distance from the Sun than on the date I picked, leaving more time to observe it. Just go to Solar System Scope and play around a bit and you'll see it for yourself.